All right, in this lesson, we're going to be looking at how to solve absolute value inequalities. Okay, I'm going to start off the lesson with a couple illustrations. So I'm going to open this link up here. And let's blow this up for you. All right, notice at the top in the blue box, you have a absolute value inequality. The absolute value of x minus 0 is less than 8. The fact that 0 is being subtracted means we're still looking at a distance from 0 here with regards to absolute value. Okay? And think about what this inequality is really asking you. We're looking for all numbers on the number line whose distance from 0 is less than 8 units. All right, slide to illustrate. From the center, I can go 8 units to the right or to the left. All numbers in between -8 and +8 would therefore be solutions. So x is greater than -8 and x is less than 8. That is a typical and compound inequality. Okay, notice the solution set. It's all numbers between -8 and 8, which can be represented with a compound and inequality. So this is just showing me that absolute value inequality is really just a shorthand way of writing a compound inequality. All right, now let's reset here. I'm going to change my center on this. So let's say I center at 1 now. Look how that changed the inequality. Now I have the absolute value of x minus 1 is less than 8. So that is now changing our definition of absolute value to now being centered at 1 rather than at 0. I can also mess around with how far I want to be. Okay, let's just move that in a little bit. I want to be 4 units from the center. Notice how that matches the inequality there. Okay, slide to illustrate. From the center, go 4 units in both the positive and negative direction. And my solution will be any number between -3 and +5. Okay. What if I want to make the center negative? All right. Notice how that changed the inequality. Now I have the absolute value of x plus 2 is less than 4. Okay, but still the same idea. From the center, go 4 units in both the positive and negative direction, and it's going to lead you to any number between -6 and 2. Okay, let's get out of that one. Look at the next one. All right, looks like the same applet, but there is actually one minor change. It's the direction of the inequality. Now I have the absolute value of x is greater than 8. I'm looking for all numbers on the number line whose distance is greater than 8 units from 0. All right, here's the illustration. Okay, so any number between -8 and +8 is less than 8 units from 0, but we want greater than 8 units from 0. So that would be all the numbers smaller than -8 or the numbers larger than 8. We have a compound or inequality here. Okay. Reset. Play around with that center a little bit. I want to be centered at 2. How about my distance? 5 units from that center. Okay. So I go 5 units in either direction, and my solution is going to be all the numbers outside of that interval. So any number less than -3 or greater than 7. Okay, so hopefully those are good illustrations to help you see visually what we're accomplishing when we solve an absolute value inequality. All right, let's take a look at an example. All right, we'd like to solve and graph the solution to the absolute value of 2x minus 2 is greater than or equal to 4. The first thing you want to do with any absolute value inequality is make sure the absolute value is isolated. That's already the case here. So then the next thing we want to pay attention to is the direction of the inequality. Okay, notice how the inequality is opening towards the absolute value. We have the absolute value is greater than the constant, right? Well, as we saw in the applet just a second ago, whenever that absolute value is greater than the constant, you're going to be able to rewrite this as a or compound inequality. Okay? So I want you to think of greater as great or. It's a easy way to remember this. Okay? We'll solve these similar to how we solved absolute value equations. We have to set up two cases. Okay? So your first case would be the positive case, 2x minus 2 greater than or equal to 4, then followed up with the word or, and then you need your negative case. So if you're going in the negative direction, you take the negative of 2x minus 2 greater than or equal to 4. All right, now solve each half on its own. And over here, remember on your first step, you're dividing or multiplying by a negative, so make sure you flip your inequality symbol, right? Oops, excuse me. -2. And make sure you carry that word or down, right? All right, now graph these to make sure graphs to a typical or. X is greater than or equal to 3, or x is less than or equal to -1. There you go. And I would write my solution all together as one statement. All right, second example. All right, notice right off the bat here that the absolute value has not been isolated. Okay, we have to start there. Think about why that is. You don't want to decide whether this should be an or inequality versus and until you're isolated, because sometimes you might end up dividing or multiplying by a negative, which will flip that inequality symbol. Okay, so let's add the 9 over. Divide by 3. Inequality did not flip. Notice the absolute value is now isolated and is less than 8. We saw that when we were working with less than in these absolute value inequalities, it led to an and compound inequality. So I want you to think of less than as less and. Okay? All right, set up your two cases. First case is the positive case, followed by and. Then you've got your negative case. Flip that inequality symbol. Carry that word and down, don't forget about it. And let's graph here. Let's see what we end up with. All right. So less than 1, greater than -7. Notice the overlap is between -7 and 1, so I should actually draw a new graph here. To just contain the numbers in between those two. And I'm going to write my solution using this notation. Okay. Pause the video, try this one yourself, and then come back and check your work. Okay, in this next set of examples, we are given the graph of what appears to be a compound inequality. And what we'd like to do is to write a absolute value inequality to represent each graph. Okay, so notice the directions. We want absolute value, not compound. This is where I think the applet illustrations really come into play. There's two things we need to consider to write these inequalities. We need to know where the center's at, as well as the distance from the center to the endpoints. Distance to endpoints. Okay, so let's look at the one over on the left-hand side first. Notice your center is right here at 1. And then these two endpoints both have a distance of 1 unit from that center, right? Okay, so taking this all into account, your absolute value will have to be of x minus 1. The minus 1 ensures that your center has been shifted 1 unit to the right. And then you need to decide, should you use a greater than or a less than symbol. See how all of the numbers are moving 1 unit or further from the center, right? So that means the distance is increasing. It's getting greater than 1 unit as you move away. So we need to have greater than or equal that distance of 1. All right, on the next one, our center is at -2. And then the distance from these endpoints to the center is 3 units. So we'll have to have the absolute value of x minus -2 or x plus 2. And this time, the endpoints are the furthest points away from the center. All the other points on the graph are getting closer to the center, right? So this means our inequality has to be less than or equal to 3 units. Okay. Moving forward, there are 2 special cases that you have to watch out for on absolute value inequalities. And I think they're pretty easy to identify. They both involve when there's a negative number once the absolute value has been isolated. All right, so look at the top example here. I have the absolute value of x is greater than -3. Think about what that's asking. It wants us to find all numbers whose distance from 0 is greater than -3 units. Well, think about this. Distance implies positive, right? So all these numbers will turn out to be a positive value no matter what. And positive numbers are always greater than negatives, right? That means our solution is all real numbers in this case. Okay? Maybe write yourself a note. Positive numbers are always greater than negative numbers. Okay. All right, and then the second example, notice I've just flipped the inequality symbol. Now we're looking for all numbers on the number line whose distance from 0 is less than 3 units. Well, once again, distance is a positive value, right? Can a positive value ever be less than a negative? The answer is no. So this would be no solution. Okay, make yourself a note. Positive numbers will never be smaller than negative numbers. All right, so keep your eyes out for those special cases as you work through these on your own. All right, one last example here, a bit of an application to an absolute value inequality. Here we have the average birth weight of a newborn baby known to be 7 pounds. However, this weight can vary by as much as 4.5 pounds. Find the range of birth weights for newborn babies by writing and solving an absolute value inequality. Once again, absolute value. All right, let's define a variable here. I'm going to use x, and we're asked to find a range of birth weights for newborn babies. So that tells me my variable should be the birth weight of a newborn baby, right? Okay, and it's telling me that the average birth weight is 7 pounds. Think of that. That's like your center. So we know that in terms of an absolute value inequality, I would have to have the absolute value of x minus 7. okay? And it says the weights can vary by as much as 4.5 pounds. So that means you can go up to 4.5 pounds in either direction, but not further, right? That will require my inequality to be less than or equal to 4.5. Okay? Now let's solve. Split it up. There's your first case. Less than, think less and your second case. Oops, excuse me. I got my signs mixed up here. This should be 11.5. And over here, that should be the 3.5. Sorry about that. Okay, so what this is saying is that your birth weights, you should expect a newborn baby's birth weight to be smaller than 11.5 pounds and larger than 3.5 pounds. So somewhere between 3.5 to 11.5 pounds. Okay. All done.